Hello, and welcome back to MA211. Before we go any farther, we should talk a little bit about using Maple to solve differential equations. Okay, so when you start up Maple, you might not have a screen that looks like this. You might be in what's called document mode. Document mode works just fine, but it's a little bit more than we need. I prefer to use worksheet mode, so if I was you, I'd go to File, New, Worksheet mode, and then you should get a screen that looks like this. Now I'm assuming that you have a fair bit of experience with Maple through your Calc 1 through 3 experience. If you don't have much experience with Maple and you'd like some worksheets to help get you started, please just go ahead and email me and I'll get you set up. Okay, so there's really only one command that we need to know, maybe two commands that we need to know for solving differential equations in Maple. So suppose that we want to solve a certain differential equation. We're just going to type dsolve. That's the equation we want. And then a list of things that we want our function to satisfy. So if we just want our function to solve an ODE, we'll type something like this. Say y double prime of t plus maybe we want y prime of t plus y of t. Maybe we want that to be cosine t. We just want to solve that equation, so we hit enter. And away it goes. That's the general solution to our ODE. Take note, this underscore C2 and underscore C1, those are the coefficients coming out in the general solution. Suppose that we want to solve an initial value problem. All we need to do is dsolve. And now the list of conditions that we want our equation to satisfy. So this time we want our equation to satisfy an ODE. Y double prime of t plus y prime of t plus y of t. Maybe we want that to be cosine t again. And now maybe there's an initial condition. I'd like y at 0 to be 1. All right. And close your parentheses. And there you go. Now you've gotten one of the coefficients gone. This is a second order differential equation. I specified only one condition. So now we have only one coefficient left. If I wanted two conditions, dsolve y double prime of t plus y prime of t plus y of t equals cosine t. I'd like y of 0 to be 1, and I'd like y prime at 0 to be 4. Oh, I didn't close my square brackets. And there you go. That does it. There's only a couple things to watch out for here. One is you have to specify the dependent variable here. So I'm saying y double prime of t, y prime of t. Maple will work if you just say y double prime. So if I do this, y double prime plus y equals 0. That works. Notice that Maple just assumes the independent variable here is x. It'll assume the independent variable is x even if I put a t on the right-hand side there. So dsolve y double prime plus y, we'll say, equals cosine of t. Okay, what's happened? It's given us a solution that has x's and t's in there. It's assumed that t is a constant thing here on the right-hand side, and that's not what we meant. So you have to be careful. If you don't specify the dependent variable, or the independent variable, then Maple will just assume it's an x, even if you put t's over here on the right-hand side. So I don't do that. I'll always specify what the independent variable is. It's a lot safer that way. We don't have to use y for the independent, or for the function here. We could say maybe I want a prime to be 5 minus a over 10. So here I've just broken my own rule, and this will assume a is a function of x. And here's the solution. So that's pretty much it. As a quick reminder, you can use solve to solve a system of equations. You can solve, maybe I want y plus x to be 5, and I'd like y minus x to be 2. And Maple will solve it for me. If I don't like the exact solutions there, maybe you solve it and it comes out in terms of sort of ugly exponentials, you can do fsolve, and then it'll give you a decimal approximation. So solve and fsolve for solving systems of equations, and dsolve for solving ordinary differential equations. And that should about do it for your Maple use for quite a while.